Topic 1.3 is factorizing. Factorizing is essentially the opposite of expanding brackets. You can put expressions into brackets by writing them as a product of their factors. Example 6. A factorize 3x plus 9. So we want to find the highest common factor between 3x and 9, which is 3. That goes outside the bracket. Then we open a bracket. 3 times something gives us 3x, so that something is x. 3 times something gives us 9. That something is 3. And that is 3x plus 9 factorized. We can check if we've factorized it correctly by expanding it. So 3 times x is 3x. And 3 times 3 is 9. So we know that we've done it correctly because we've got 3x plus 9. Let's try B. X squared minus 5x. The highest common factor between x squared and 5x. So the highest value they both have in common is x. X times x gives us x squared, and x times minus 5 gives us minus 5x. So we know that x squared minus 5x factorizes x, open bracket, x minus 5, close bracket. And once again we can just check this by expanding it. X times x is x squared, and x times minus 5 is minus 5x. So we know we've done it correctly. C. 8x squared plus 20x. Well, the highest common factor between 8x and 20x, 8x squared and 20x, well, 8 and 20, the highest common factor is 4, and x squared and x, the highest common factor is x. 4x times 2x gives us 8x squared, and 4x times 5 gives us 20x. D. 9x squared y plus 15xy squared. Well, the highest common factor between 9 and 15 is 3. The highest common factor between x squared and x is x. The highest common factor between y and y squared is y. Now, to get from 3xy to 9x squared y, we need to multiply by 3. And we can see there's x to the power of 2 there, and we've only got 1x, so we need one more. And to get from 3xy to 15xy squared, we need to multiply it by 5. And we want y squared, but we've only got y, so inside the bracket we have another one. 3x squared minus 9xy. The highest common factor between 3 and 9 is 3. And the highest common factor between x squared and x is x. You can see that they don't have a y in common, so that won't go outside the bracket. 3x times x gives us 3x squared minus 3y. Now, we'll move on to factorizing quadratics. A quadratic expression has the form ax squared plus bx plus c, where a, b and c are real numbers but they are not equal to 0. An example of a quadratic equation would be x squared plus 6x plus 5. This is of the form ax squared plus bx plus c, but in this case a is 1. Since we wouldn't need to write 1, we can consider that there is no coefficient to x squared. Now, in order to factorize this, what we would need to do is multiply a and c. In this case, we don't have an a value, it's just 1. So we need to find factors of c that add up to give us b. And that would be 5 and 1. And then all we have to do is pop it into brackets to factorize it. X plus 1, x plus 5. And that is x squared plus 6x plus 5 factorized. Now to check this, we can expand it. So x times x is x squared. X times 5 is 5x. X times 1 is x. And 1 times 5 is 5. Then once we've collected like terms, we get x squared plus 6x plus 5. Now, we can also try the method given in the textbook, although this may be more useful when there is a coefficient to x squared that is not 1. So we can try the method given in the textbook, and that is as follows. We have x squared plus 6x plus 5. Using the method in the textbook, we are going to treat the coefficient to x squared as 1, and then we're going to multiply 1 and 5. 1 times 5 gives us 5. We then need to find factors of 5 that add up to 6, which we know to be 5 and 1. We then rewrite the expression, but instead of writing 6x, we will be writing 5x and x. So x squared plus x plus 5x plus 5. And we can see how this has split up into x and 5x. The next step is to factorize each half respectively. So I will be factorizing x squared plus x, which gives me x plus 1, and then 5x plus 5, which gives me 5x plus 1. I know I have done it correctly because that bracket is exactly the same. So the last step is we take out the similar bracket, and whatever's left over, which is x and 5, goes into the second bracket, x plus 5. And we can see that we've got the same answer, x plus 1, x plus 5, just using a different method. Like I said, this method would be more useful when we are factorizing a quadratic with a coefficient to x squared. And that just means any number before x that is not equal to 1. A key principle in factorizing is called difference of two squares. And it is as follows: x squared minus y squared equals x plus y, x minus y. For example, if we had x squared minus 9, we can see that this is a squared number, and this is also a squared number, we know that. So it would follow the same format of x plus y, x minus y. Meaning, we have to find the square root of each of the values. So the square root of x squared is x, and the square root of 9 is 3. So the first bracket would be x plus 3, and the second bracket would be x minus 3. Example 7. A. Factorize x squared minus 5x minus 6. So here we're going to find factors of minus 6 that add up to minus 5. So they need to add to minus 5, but are products of minus 6. So minus 6 and 1. And then we can simply just put that into brackets. So x minus 6, x plus 1. B. X squared plus 6x plus 8. So here we need to find factors of 8 that add up to 6. That would be 2 and 4. So we are left with x plus 2 and x plus 4. C. 6x squared minus 11x minus 10. Now this is where we will use the second method because we have a coefficient to x squared that is greater than 1. The coefficient that we have is 6x. So we're going to do 6 times minus 10, which gives us minus 60. And then factors of minus 60 that give us minus 11. So that would be minus 15 and 4. So now what we need to do is rewrite our quadratic, but instead of writing minus 11x, we're going to write minus 15x plus 4x. 6x squared plus 4x minus 15x minus 10. Now the reason I switched 4 and minus 15 around is because it's much easier to factorize 6x squared and 4x, and it's much easier to factorize minus 15x and minus 10. So we can make decisions like that that will make our factorizing process much easier. So now when we are factorizing 6x squared plus 4x, the highest common factor between 6 and 4 is 2, highest common factor between x squared and x is x. So that leaves us with 3x plus 2. Minus 15x minus 10, the highest common factor is minus 5. That leaves us with 3x plus 2. We can see we've done it correctly because the bracket is the same, and that leaves us with 3x plus 2, 2x minus 5. D. X squared minus 25. Here I can see that x squared is a squared number and 25 is also a squared number. The square root of x squared is x and the square root of 25 is 5. So we'll apply a difference of two squares where we do x plus 5 and x minus 5, and that is the expression factorized. 4x squared minus 9y squared. Here I can also see that 4x squared has a square root of 2x and 9y squared has a square root of 3y. So I can apply difference of two squares again, and it will simply be 2x plus 3y, 2x minus 3y. Moving on to example 8. Factorize completely x cubed minus 2x squared. So initially I can see that they have got x squared in common. So I will take that out, and that leaves us with x minus 2, and I can leave it at that. X cubed minus 25x, I can see they have an x in common, so that leaves us with x squared minus 25, and then I can see that these two are both square numbers, so I can apply the difference of two squares. That leaves me with x plus 5, x minus 5. C. X cubed plus 3x squared minus 10x. Well, they all have an x in common, so I'll take that out first of all. That leaves me with x squared plus 3x minus 10, which is a quadratic. So what I will be doing is finding factors of minus 10 that add to give me 3. One must be negative, one must be positive, so I will go with minus 2 and 5. And then I can simply put it straight into brackets, x minus 2, x plus 5. That brings us to the end of the examples. In the next video, I'll be completing exercise 1C.